You are cruising down the interstate on a freezing winter morning at 70 miles per hour. Your windshield suddenly starts to fog up, and instead of just blindly reaching down to crank a tactile physical dial, you have to take your eyes completely off the road to tap through 3 different submenus on a massive iPad glued to your dashboard. By the time you navigate through the infotainment software and finally locate the tiny defroster icon, you have already drifted halfway out of your lane. Automakers are absolutely obsessed with packing every single vehicle function into giant touchscreens, and it is quietly creating a massive safety hazard while driving up the long-term cost of ownership. Sure, that massive, sleek glass panel looks incredibly futuristic on the dealership lot when you are sitting still, but in a moving vehicle bouncing over potholes, it is an absolute ergonomic nightmare. You lack the physical muscle memory that comes with traditional knobs. Even worse, if the central computer module glitches, the screen freezes, or you experience a sudden electrical fault, you instantly lose complete control over your air conditioning, your heater, your heated seats, and your windshield defrosters. Imagine dealing with a cracked screen out of warranty. You are looking at a $2,000 or maybe even $3,000 repair bill at the dealership just to be able to turn on your AC. Give me chunky, tactile physical dials any day of the week, the kind you can operate with thick winter gloves on without ever taking your eyes off the asphalt. We're about to look at some of the most annoying modern car features that are secretly costing you thousands in repairs. But before we get into the absolute chaos happening right beneath your fingertips, if you want to keep your ride running right without paying insane dealership labor rates, go ahead and hit that subscribe button right now. So let us talk about the steering wheel itself. What used to be a simple, elegant circle with a horn pad in the middle has slowly morphed into a chaotic mess of tiny toggle switches, capacitive touchpads, and random scrolling wheels. Automotive engineers originally put these controls on the wheel so you would not have to reach over to the radio, but now they have crammed so many functions into a space the size of a deck of cards that it completely defeats the entire purpose. Every single manufacturer has a totally different layout. Sometimes the volume is a physical toggle on the left, sometimes it is a touch-sensitive slider on the right that you accidentally brush with your palm, and sometimes you have to do actual finger gymnastics just to skip a track or answer a phone call. When you have to look down at the steering wheel to figure out which identical black button hangs up a phone call, you are risking a major rear-end collision. And from a mechanic's perspective, these densely packed control pods age terribly over time. After a few years of baking in the hot summer sun and absorbing the natural oils and dirt from your hands, those buttons get incredibly sticky, the internal electrical contacts wear out, and the inputs start lagging heavily. Next thing you know, you are paying a shop hundreds of dollars to carefully pull the explosive airbag module out and replace the entire steering wheel switch assembly just because you cannot turn down the radio. Speaking of things that wear out way too fast and cost an absolute fortune to replace, we have to talk about the dreaded engine auto start-stop systems. You pull up to a red light, take your foot off the gas, and the engine completely shuts off, leaving you sitting there in sudden silence. The second you lift your foot off the brake pedal, the engine violently shudders back to life, shaking the entire cabin. Automakers loudly claim this technology saves you a massive amount of fuel over the life of the vehicle, but the mechanical math just does not add up in the real world. You might be saving a tiny fraction of a gallon of gas every week, maybe bumping your city MPG up by 1 single point, but you are putting an astronomical amount of stress on your starting and charging system. A standard starter motor from 20 years ago was designed to start the car maybe 4 or 5 times a day. Modern vehicles with auto start-stop are forcing that heavy-duty starter motor and the flywheel ring gear to engage 50 or 60 times on a single commute across town in heavy stop-and-go traffic. To support this massive, constant electrical draw, manufacturers are forced to use massive, highly expensive, absorbent glass mat batteries, commonly known as AGM batteries, which easily cost upwards of $300 to replace. When that heavy-duty starter inevitably burns out prematurely from being overworked, the intensive labor and expensive parts bill will completely wipe out any microscopic fuel savings you accumulated over the past 5 years. It is basically an engineering band-aid designed strictly to meet federal emissions targets, and it passes the massive long-term repair costs directly to you, the second or third owner. And this massive overcomplication of simple, proven mechanical systems brings us right to the electronic parking brake. For decades, we had a highly reliable steel cable attached to a heavy mechanical lever beside the driver's seat. You pull it up, it physically locks the rear wheels. It was completely foolproof. Now, automakers have replaced that vital safety mechanism with a tiny little plastic switch on the center console that activates electric motors mounted directly on the rear brake calipers. When these electronic actuators fail, and trust me, they do fail frequently, you are literally stranded. The brake can electronically lock up while parked in your driveway, freezing the heavy vehicle exactly where it sits. Sometimes they refuse to release in freezing weather because winter moisture gets into the plastic housing and freezes the small plastic gears completely solid. If your battery completely dies while the electronic parking brake is engaged, you cannot just shift into neutral, hook up a tow strap, and pull the car onto a flatbed truck. The rear wheels are permanently locked until you get jump leads on the battery or crawl under the car and physically unbolt the actuator motors from the brake calipers. On top of that, if you want to change your own rear brake pads in your garage on a Saturday afternoon, you can no longer just push the brake piston back with a simple C-clamp. You are forced to buy a specialized bidirectional scan tool just to command the computer to retract the electronic parking brake into service mode. It takes away the control from the driver and forces you to go back to the dealership for basic routine maintenance. Have you noticed that modern luxury cars and a lot of new electric vehicles are completely doing away with regular door handles? In the relentless pursuit of a slightly better aerodynamic drag coefficient to boost their range numbers, we now have flush-mounted electronic door handles that magically pop out when you walk up to the car with the key fob. They look incredibly sleek and futuristic on a showroom floor, but from a real-world reliability and safety standpoint, they are an absolute disaster waiting to happen. Inside the door panel, there are tiny electric motors, delicate microswitches, and complex wiring harnesses solely dedicated to pushing a piece of plastic outward, just so you can get into your own vehicle. During a harsh winter, when freezing rain coats the side of your car in a heavy sheet of solid ice, those weak little electric motors do not have the physical torque to punch through the ice layer. You are literally locked out of your own car in freezing temperatures because the handle will not deploy. Even worse, if the vehicle loses total electrical power in a severe collision, first responders cannot easily grab a handle to pull the door open, creating a massive safety hazard. We took a beautifully simple mechanical hinge that has worked perfectly for a century and turned it into a complex electronic failure point just to look highly advanced. We are about to look at a feature that is supposed to make your life infinitely easier at the gas pump, but is actually triggering false engine lights and forcing massive repair bills. But right before I explain exactly why this specific emission system fails and how you can attempt to prevent it from throwing a permanent evap code on your dashboard, hit that subscribe button so you do not miss the deep dive mechanical secrets we post here every single week. So let us talk about capless fuel fillers. When you go to the gas station to fill up, there is no longer a traditional plastic gas cap to unscrew. You just shove the heavy metal gas pump nozzle directly through a little spring-loaded metal flap. It sounds great on paper because you never have to worry about losing your gas cap or forgetting to tighten it and triggering a check engine light. However, that little spring-loaded flap is the absolute only barrier keeping the highly pressurized fuel vapors inside your gas tank and keeping the outside dirt, road dust, and rainwater out. The heavy metal nozzles at the gas station are incredibly abrasive, and every single time you slam one in there, you are wearing down the delicate rubber seal around that internal flap. Once that seal gets a little bit of grit stuck in it or the spring loses its tension over time, your car's computer instantly detects a vacuum leak in the evaporative emissions system and throws a check engine light, specifically a small leak-detected code that will instantly fail your state inspection. With an old-school system, you just walked into the parts store and bought a brand new gas cap for $15. With a capless system, you cannot just replace the tiny flap. You usually have to buy an entirely new fuel filler neck assembly, which often requires a mechanic to remove the rear wheel, pull down the plastic inner fender liner, and sometimes even drop the evap charcoal canister just to reach the mounting bolts. To make matters even worse, if you ever run out of gas on the side of the highway, you absolutely cannot pour gasoline out of a standard red plastic jerry can into a capless tank. The internal anti-siphon flap will completely block the flow and spill raw fuel all over your shoes. You have to tear apart your trunk in the dark to find the specific plastic funnel adapter the manufacturer hid next to the spare tire just to add emergency fuel. Finally, we deeply need to address the massive elephant in the engine bay, which is the industry-wide shift towards tiny displacement turbocharged engines. Almost every major automaker has completely ditched their highly reliable, naturally aspirated V6 engines in favor of small, heavily boosted 2-liter 4-cylinder motors. They do this strictly to meet the strict Kelley Blue Book and federal fuel economy standards on paper, while still delivering decent horsepower numbers for the brochures. But forced induction means extreme heat and extreme cylinder pressures. A modern turbocharger spins at upwards of 150,000 RPM and relies heavily on your engine oil to keep its bearings from melting down. All that extra boost pressure puts a massive strain on your head gaskets, your piston rings, and your entire cooling system. You are violently cramming way more air and fuel into a tiny physical space, causing the engine to work at its absolute maximum mechanical limit just to get a heavy 5,000-pound SUV moving at highway speeds. When a naturally aspirated engine gets old, it might burn a little oil, or lose a tiny bit of compression, but it will generally keep running strong for hundreds of thousands of miles. When a highly stressed turbocharged engine has a major failure, it is usually violently catastrophic. If the internal bearings in the turbo fail, it can send raw metal shrapnel directly into the engine block or pump all of your oil straight into the hot exhaust pipe, resulting in a devastating $5,000 repair bill in a matter of seconds. Yes, turbos are fun, and they provide a great surge of low-end torque that pushes you back in your seat, but you are effectively trading a decade of reliable, stress-free longevity for a brief moment of forced induction thrill. A naturally aspirated engine is built with pure simplicity and endurance in mind, whereas a turbocharged engine introduces vastly more heat, far more moving parts, and significantly more financial risk into your daily commute. The automotive industry is constantly trying to reinvent the wheel, but a huge portion of these modern features are just unnecessary. Over-engineered complications that make vehicles significantly harder to repair and vastly more expensive to own over the long term. From massive glass touchscreens replacing durable physical dials to electronic parking brakes that leave you totally stranded, all this new bleeding-edge technology eventually breaks down and leaves the second or third owner holding the massive repair bag. I want to hear exactly what kind of crazy electrical gremlins or annoying modern car features you are dealing with right now. Head down into the comments section and tell me what the most frustrating feature is on your current daily driver, or drop any weird check engine error codes or sudden MPG issues you are currently trying to diagnose in your garage. Let us get a solid community conversation going down there and help each other figure out these absolutely annoying automotive headaches. If you got some solid, actionable value out of this breakdown today and want to keep your ride running flawlessly for years to come, smash that subscribe button, give the video a massive thumbs up, and I will see you all in the next garage session. Keep those wrenches turning and drive safe out there.